Massive dust storms choke cities, bury crops, and shut down airports. But without dust carried by storms like these, some ocean waters would receive far fewer nutrients. Because some desert dust is not just dirt, it is fertilizer in disguise. This is how deserts secretly feed the sea. The ocean looks full from above, but near the surface, some waters are short on the minerals that life needs to grow. Not more water, not more sunlight. Minerals. Tiny ingredients like iron, phosphorus, and nitrogen. And when those ingredients are missing, microscopic life stays stuck in first gear. So the ocean waits, and weirdly enough, the desert answers. The Sahara is the famous one, the dust machine everyone recognizes from satellite images. But the Indian Ocean story is not one desert saving one ocean. It is a whole dust network. Arabia can feed the Arabian Sea. Dust from northwestern India and surrounding drylands can contribute toward the Bay of Bengal. Southern Africa can send dust toward waters near Madagascar. Different deserts, different winds. Same basic trick. Land breaks apart, and the sky carries the pieces away. This is the part that sounds fake until you see it from space. Tiny bits of desert can travel thousands of kilometers through the air. The wind does not care about borders. It moves dust over countries, mountains, and oceans. And the trip matters, because the sky can change the dust on the way. Dust is not automatically useful. Some minerals are locked inside it, but as dust passes through moisture, sunlight, and acidic gases in the air, some of those nutrients can become easier for life to use. That is what bioavailable means, not just present, usable. So what starts as a destructive storm on land can become a delivery system for the sea. When that dust finally reaches the ocean, nothing dramatic happens at first. No giant wave, no explosion, just minerals entering the top layer of water. But if the water was waiting for exactly those minerals, the response can be fast. This is where phytoplankton enter the story. They are microscopic plant-like organisms, easy to ignore, impossible to replace. Give them the missing nutrients, and they can multiply into huge blooms visible from space. That green color is not decoration. It is the food chain switching on. One of the clearest Indian Ocean examples happened near Madagascar. After severe dryness in southern Africa, dust lifted from the land and moved over the ocean. It reached nutrient-limited waters southeast of Madagascar, and researchers linked that dust arrival to the strongest phytoplankton bloom seen there in that region in 2 decades. That is the rule. Dust does not always create a bloom, but in the right place, at the right time, it can unlock one. And once the bloom starts, the food chain starts climbing. Tiny grazers eat the phytoplankton, small fish eat the grazers, bigger fish follow them. The first meal is microscopic. The impact is not. Somewhere in that chain, there is a little piece of desert history, not as sand, not as a storm, as an ingredient. There is also a carbon layer here. Phytoplankton pull carbon dioxide from the water as they grow. Some of that carbon moves through the food chain. Some can sink as tiny particles called marine snow. This does not make dust a climate fix, but it does show how land, air, ocean, and life are connected. So yes, dust storms can be dangerous. They damage health, crops, roads, and cities. But nature is rarely just one thing. What looks like land breaking apart can become life assembling itself at sea. The ocean is sometimes hungry for land, and the desert answers in dust. So the next time the sky turns brown, remember, somewhere far away, the sea may be turning green. And that's a way of nature's sneezing in one place and feeding in another. If you enjoyed this video, click that like button and subscribe to the channel for more such stories.